Welcome back to the introduction to design of central AC and chiller system. We were discussing the schematic. Design of AC system would mean selecting the cooling coil, that is what capacity, what tonnage of AC system I should purchase from the market. Second thing is what should be the temperature of this cooling coil, surface temperature of the cooling coil. Third would be what temperature finally would be the temperature of the supply air which would go to the room, and what would be its relative humidity, so that the occupants inside this room they feel comfortable. In the last video we discussed about the inside design conditions, that is we said that the temperature and humidity which are to be decided beforehand so that the occupants would feel comfortable, they are known as inside design conditions. Similarly, we talked about outside design conditions and we said that they are the conditions which are to be decided before the load calculations, that is they are the temperatures and humidity one has to decide before the load calculations, and they would have an influence on ultimately the capacity of the cooling coil. So in this lecture we would see what values we take for the inside design conditions and what values we take for the outside design conditions. Similarly, we would also see how to do the load calculations, how to calculate the sensible load and the latent load in brief. We said that the inside design conditions, the outside design conditions and the load will ultimately influence the capacity, the tonnage of the AC system. Inside design conditions are defined by ASHRAE, American Society for Heating, Refrigeration and Air Conditioning Engineers. And there is a standard to it. You can Google this standard, standard 55 2013. According to this ASHRAE, the inside design conditions are to be selected on the basis of thermal comfort for comfort air conditioning applications. By thermal comfort, we mean the state of mind or the condition of mind which would give the occupant satisfaction, a sense of satisfaction with the thermal environment. Now, at what temperatures would human being feel comfortable? So, this is the temperature range at which human beings feel comfortable. Instead of giving you the range of the dry bulb temperature and humidity, I have given a term called as ET. So, what is this ET? So the ET is an effective temperature. So it is a representative temperature which will capture the combination of the dry bulb temperature and the humidity at which the occupants would feel comfortable. So the name itself would indicate that this is not the actual temperature. This is an effective temperature, means it is a combination of temperature and humidity at which the occupants would feel comfortable. So how is this effective temperature calculated? So effective temperature is calculated in a test room wherein a standard relative humidity is maintained, either 100% relative humidity is maintained or 50% relative humidity is maintained, and the comfortness of the individuals is tested. So that would give you a range of effective temperatures at which human beings would feel comfortable. Now, as per ASHRAE, if the climate is hot and dry, the effective temperature would range between 21.1 to 26.7 degrees centigrade. It means that if the effective temperature is in this range, then human beings would feel comfortable. Similarly, if the climate is humid, then the effective temperature range given by ASHRAE is 22 degrees centigrade to 25.6 degrees centigrade. So these are the values which have been worked out based on the extensive experimentation by ASHRAE. But by thumb rules, if I want to design an AC system, or a professional wants to design an AC system, he would also use some thumb rules. So for example, he might choose a dry bulb temperature of around 25 plus or minus 1 degree centigrade and a relative humidity of 50 plus and minus 5 degree centigrade. So now how these values are decided? These values would be decided by some trial and error. So this is how the inside design conditions are selected. So first episode, that is, we have selected what temperature and what humidity one has to maintain inside this room. This inside design conditions are also plotted graphically in the form of comfort chart. Comfort charts are interesting charts in which you would find a psychrometric chart, a special type of psychrometric chart on which some comfort zones are drawn. So there will be a separate comfort zone, comfort region for summer, and there will be a separate comfort region for winter. So within that range, within that range, one can choose the values, a combination of a variable temperature and specific humidity. And experience says that if you choose that region, then occupants would feel comfortable. Now, how to select the outside design conditions? So for selecting the outside design conditions, we need to have the weather data from the nearby weather station. Once we get the weather data, then we would see that for summer especially, the maximum temperature will be between 1 to 4 p.m. and the relative humidity is minimum there. So now which temperature should one choose? If you choose the highest temperature from the data of the summer month, then there would be a different size of AC system. If you choose the minimum temperature, that would give you a different size of temperature. So if you choose the minimum temperature, your capacity, tonnage capacity would be lower. If you choose the maximum temperature, your capacity would go higher. So the sciences or the suggestions from ISHRE is you choose the mean monthly maximum of dry bulb temperature. So what is the suggestion? One has to choose the mean monthly maximum of dry bulb temperature. So based on the data of the summer months, you need to find the mean of it, the dry bulb temperature, and that mean value. Once you get that mean value of dry bulb temperature, the corresponding wet bulb temperature has to be chosen. Please note that we are not talking about the mean wet bulb temperature. We are talking about the mean dry bulb temperature and corresponding wet bulb temperature. Once you get that, that will becomes our outside design conditions for AC design. So now we have chosen the inside design conditions and we have chosen the outside design conditions. Now let us consider a system where you are not supplying any fresh air or ventilation air. The second case would be you might supply some fresh air to the room. So case 1 and case 2. If you take case 1, the load would be different, the capacity of the cooling coil would be different. If you take case 2, the capacity of the cooling coil would be different. This has to be understood. If you are supplying the fresh air, your air flow rate would be different. Your temperature at which the conditioned air enters the room would be different. So how much should be the flow rate? At what temperature should the conditioned air be supplied? And what should be the mix of ventilation and the recirculated air? These are called as supply design conditions. So there are three things. One is the inside design condition, other is the outside design condition, and the third parameter is the supply design condition. By supply design condition, we mean what temperature and what relative humidity one is maintaining for supply to the room and at what flow rate we are supplying the air to the room. The third parameter in the design is called as a load calculation. So for summer conditioning, your load calculations would mean calculating the heat gain inside the room. So basically there are three things. We would do an elaborate video on load calculations. But for this present video, we would say that load calculations would include the load, that is the heat gain, through the walls of the room, through the windows of the room, through the partition, through the ceiling, and through the floor. Similarly, the heat gain would be because of the occupants which are working in that room, because of certain appliances and lighting in the room. Then there would be an additional load on the AC system, and that has to be because of the ventilation of fresh air. There has to be because of the heat gain, because of the ducting system which you are laying, the heat coming from the fans and pumps which are in the system, which is called a system heat gain. So all these things need to be considered and in your load calculations. So the load on the room and AC system would then be the room load, that is the sensible load and latent load because of occupants, heat transfer through the walls, etc. Then there is a term called as effective room load. Now this effective room load is basically an addition of some air which is escaped the AC equipment and entered into the room. So this we'll discuss in detail again. The third is the equipment load. So as I said, there is a room load, there is an effective room load, there is something called as equipment load, and this equipment load would include the ventilation load, and all these things ultimately finally we would calculate is the grand heat load or grand total load, which is again the combination of grand sensible load and grand latent load. By sensible load I mean the load which would increase the temperature in summer air conditioning, and latent load means the load which would increase the moisture content inside the room because of certain things. So once you get this grand total load, so then we can finally arrive at the capacity of the coil in TR, the coil surface temperature, also known as apparatus dew point temperature or ADP, the supply airflow rate, and in what proportion I should mix the fresh air with the recirculated air. So this would be the outcome of the design. So what exactly is design of AC system? What would be the outcome of AC system design? The outcome of AC system design is to calculate the capacity of the coil in tons of refrigeration, deciding the surface temperature of the coil, also known as apparatus dew point when you are talking about cooling and dehumidification, and then finally fixing the flow rate, how much air needs to be supplied to the room so that the occupants would feel comfortable. So this is what is called as design of AC system, or more specifically design of cooling coil if the application is comfort air conditioning and we are talking about summer air conditioning. Thank you.